Hi, our topic will be neutralization.
So now, we are going to look at this situation where there's a private lab owned by a scientist, and while doing an experiment, he spilled 25 milliliters of sulfuric acid with 0.02 molarity. He then immediately took an amount of sodium bicarbonate to neutralize the spilled acid.
So, definition of neutralization. A neutralization reaction is when an acid and a base react to form water and a salt and involves the combination of H plus ions and OH minus ions to generate water. The neutralization of a strong acid and strong base has a pH equal to 7. The neutralization of strong acid and weak base will have a pH of less than 7, and conversely, the resulting pH when a strong base neutralizes a weak acid will be greater than 7.
Guys, as we all know, acid have negative impacts. When sulfuric acid is exposed towards the environment, it may cause harm towards the environment and also to human health system. When sulfuric acid is exposed to the environment for a long period of time, the sulfuric acid may evaporate and cause acid rain to happen. Other than that, as we are speaking about human health system, the sulfuric acid, when it is exposed, it produces a substance called sulfur trioxide, which can enter our respiratory tract when we inhale it. This sulfur trioxide will deposit in our lungs when we inhale it.
Why sodium bicarbonate? Reaction of acid with sodium bicarbonate is a common method for neutralizing acid and base spills. Advantage of sodium bicarbonate is amphoteric, hence reacts with acid and bases. Below is equations of sulfuric acid with sodium bicarbonate and sodium hydroxide. Furthermore, as it is relatively innocuous in most situations, there is no harm in using a sodium bicarbonate. Both substances will neutralize sulfuric acid perfectly well, but solid sodium hydroxide is more corrosive to human skin than sodium bicarbonate. Sodium bicarbonate is generally safe to handle and is useful in dealing with acid spills, and its hydrogen ions concentration is much less than the solution of sodium hydroxide with the same molarity. So, a spilled solution of sodium bicarbonate will be less caustic than the solution of sodium hydroxide.
Next part is methodology. We collected 25 ml of 0.02 molarity sulfuric acid to test out by using direct titration method. First of all, transfer 25 ml of 0.02 molarity sulfuric acid into the conical flask. After that, add a few drops of phenolphthalein indicator into the acid. Then, fill in the burette with 2 molarity of sodium bicarbonate. Next, titrate sodium bicarbonate into the acid while stirring it until it turns pink. Record the initial and final of burette reading about 3 times to get the average volume of sodium bicarbonate used. So we get the average volume of sodium bicarbonate used is 30 ml. After that, we proceed to calculate the mole and mass of the sodium bicarbonate used to neutralize spilled sulfuric acid.
As for the calculation, it was based on methodology. First, we need to do a balanced equation and find the mole for sulfuric acid and sodium bicarbonate. The stoichiometric ratio is not 1:1, so we need to divide by stoichiometric ratio and compare. Hence, we get sulfuric acid as the limiting reactant. We get to know that 1 mole of sulfuric acid needed 2 mole of sodium bicarbonate. So 0.005 mole of sulfuric acid needed 0.01 mole of sodium bicarbonate. Now we can find the mass of sodium bicarbonate needed to neutralize the sulfuric acid.
So in conclusion, in this experiment, 0.842 gram of sodium bicarbonate is proven could neutralize the acid of spill. Furthermore, we can see the method, which is neutralization, used in this case can prevent bad effect of H2SO4 to the human and environment.